Coastal cities across the world are at a high risk of flooding by the end of the century, according to the results of a shocking new study. Sea levels are set to rise by at least 2 feet, 65 centimeters, by 2100, more than twice as much as predicted by some models. Melting ice in Greenland and Antarctica is largely responsible for the trend, experts say, described by the team as a game changer in the climate change debate. It could mean places as far flung as South Florida, Bangladesh, Shanghai and parts of Washington, D.C. being engulfed by rising waters. Scroll down for video. The finding was made by a team of U.S. researchers, including the University of Colorado. In the first analysis of its kind, they used 25 years of satellite data to show current climate models which predict sea levels will rise at an increasing rate are correct. They found that, since 1993, ocean waters have moved up ashore by an additional 1 millimeter, 0.04 inches, per decade. That's on top of a 3 millimeter, 0.1 inch, steady annual increase. This acceleration would mean an additional millimeter sea rise per year for each of the coming decades. If the oceans continue to change at this pace, sea levels will rise by 65 centimeters, 2 feet, by the end of the century. Models that assume the rate of increase remains constant predict a rise of about 30 centimeters, 1 foot. New Orleans could become an island guarded by levees and floods ravage parts of the east coast of the U.S. with far greater frequency. About the results study co-author Dr. Gary Mitchum, Associate Dean and Professor at the University of South Florida, said, "I think this is a game changer as far as the climate change discussion goes." For example, the Tampa Bay area has been identified as one of 10 most vulnerable areas in the world to sea level rise, and the increasing rate of rise is of great concern. Rising concentrations of greenhouse gases in Earth's atmosphere increase the temperature of air and water, which causes sea level to rise in 2 ways. First, warmer water expands, and this thermal expansion of the oceans has contributed about half of the 7 centimeters, 2.7 inches, of global average sea level rise observed over the last 25 years. Second, melting land ice flows into the ocean, also increasing sea level across the globe. The team looked at satellite altimeter measurements taken since 1992, including data taken from the current Jason 3 satellite mission. Episodes like volcanic eruptions can create variability in their measurements. The eruption of Mount Pinatubo in 1991 decreased the global average sea level just before the Topic/Poseidon satellite launch, for example. In addition, global sea level can fluctuate due to climate patterns such as El Niños and La Niñas, the opposing phases of the El Niño Southern Oscillation, ENSO. These events influence ocean temperature and global rainfall patterns. Experts used climate models to account for the volcanic effects and other datasets to determine the ENSO effects. This let them uncover the underlying sea level rate and acceleration over the last quarter of a century. They used data from the GRACE satellite gravity mission to determine that the acceleration is largely being driven by melting ice. The team also used tide gauge data to assess potential errors in the altimeter estimate. Tide gauge measurements are essential for determining the uncertainty in the global mean sea level (GMSL) acceleration estimate, according to the team. However, satellites give a better view of sea level rise, because samples are collected over the open ocean, rather than just along the coastline. This acceleration, driven mainly by accelerated melting in Greenland and Antarctica, has the potential to double the total sea level rise by 2100 as compared to projections that assume a constant rate, added Steve Narum, professor of aerospace engineering sciences at the University of Colorado, who led the study. This is almost certainly a conservative estimate. Our extrapolation assumes that sea level continues to change in the future as it has over the last 25 years. Given the large changes we are seeing in the ice sheets today, that's not likely. The full findings of the study were published in the journal Proceedings of the National Academy of Sciences,